Determine the values of x for which mod 2x minus 4 is greater than or equal to x minus 5. So we could do this by sketching. If we think about mod 2x minus 4, it's 0 when x is equal to 2. So we can say that this is 2x minus 4 if x is greater than or equal to 2, and negative 2x plus 4 if x is less than 2. Then we have the mod x minus 5, which is 0 when x equals 5. So that's going to be x minus 5 for x greater than or equal to 5, and negative x plus 5 when x is less than 5. So we could make a sketch of this. So for 2x minus 4, we know the 0 is at 2. And then it's going to be 2x minus 4 over here, and negative 2x plus 4 over here. And then we can do a sketch for mod x minus 5. So that's going to be here. Now obviously it's not as steep as the mod 2x minus 4, because the gradient of this one here is 2, and the gradient of this one here is 1. And the same sort of thing over here. It's not going to be as steep as the other one, so it will go out like that. So we can see that there are two intersections, call them 1 and 2. For intersection 1, we're looking at where 2x minus 4 is equal to negative x plus 5. And that would give me 3x equals 9. So x would be equal to 3. For intersection 2, again, this limb over here is the negative x plus 5. This time it's going to be equal to this limb, which is negative 2x plus 4. So that gives me x plus 5 is equal to 4, and therefore x is negative 1. Looking at the inequality, we can see we're looking for when the 2x minus 4, that's the blue one, is above the pink one. So in other words, that's going to be this way and this way. That's where the blue is above the pink. So it's going to be real values. X is less than or equal to negative 1, or x is more than or equal to 3. Now we can certainly do that by squaring both sides. So what we do is look for intersections first and put these equal to each other. And then if we square them, we know that we don't need the modulus. Like so. So we've got 4x squared minus 16x plus 16 is x squared minus 10x plus 25. So that's 3x squared minus 6x minus 9 is equal to 0. All of those divide by 3, so x squared minus 2x minus 3 is equal to 0, which gives me x plus 1, x minus 3 is equal to 0. So x is equal to negative 1, x is equal to 3. So we can see that's the same solutions that we got up here. And then you would just point test. So we've got negative 1, we've got 3. So you'd look at something in between, something like 0. And remember that the original inequality was 2x minus 4 in modulus was greater than or equal to the modulus of x minus 5. So if we point test that with a 0, you would have modulus of negative 4 is greater than or equal to modulus of negative 5, which would mean 4 is greater than or equal to 5, and that's not true, so we don't want the middle section. If you try it with something out here, like negative 2, what would we get? So we'd have, so if x is negative 2, that's going to be modulus of negative 8 is greater than or equal to the modulus of negative 7, and that would give me 8 is greater than or equal to 7. So that's true, and you'd find it was true in this section as well.